Since we've already looked at quadrant 1 of the unit circle, let's go ahead and look at the complete unit circle. Notice the patterns to help you establish the values that we need to memorize. Unit circle has a radius of 1. First, I'm going to start by labeling the degree measures around the circle. 0 degrees, 90 degrees, 180 degrees, 270 degrees, and a complete revolution is 360 degrees. In quadrant 1, halfway between 0 and 90 is 45. 45 plus 45 is 90, which I already have labeled. Add 45 again, and we get 135. Add 45 again, we get 180. Add 45 again, 225. Add 45 again to get 270. Add 45 to get 315, and add 45 to get 360. Look again in quadrant 1. The spoke that's closest to the x-axis represents 30 degrees. The next open spoke is 30 more degrees. 60 plus 30 is 90. It's already labeled. Add 30. We get 120. Add 30, 150. Add 30 to get 180. Add 30 to get 210. Add 30 to get 240. Add 30 to get 270, which is already there. Add 30, we get 300. Add 30 to get 330, and another 30 degrees puts us at 360 degrees. Now let's talk radians. We've got 0 pi and 1 pi. All the way around the circle is 2 pi. Halfway between 0 and 1 pi is a half of a pi. We call that pi over 2. Halfway between 1 and 2 is 3 halves, or 3 pi over 2. In quadrant 1, half of pi over 2 is pi over 4. If I take pi over 4 plus pi over 4, that's 2 pi over 4, which happens to already be pi over 2 in reduced form. Add pi over 4 again to get 3 pi over 4. 4 pi over 4 is where pi is. 5 pi over 4, 6 pi over 4 is the same as 3 pi over 2. 7 pi over 4 and 8 pi over 4 is a full rotation. Simplifies to 2 pi. In quadrant 1, the spoke closest to the x-axis is pi over 6. 2 pi over 6 can be reduced to pi over 3. 3 pi over 6 reduces to pi over 2. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6. 6 pi over 6 reduces to pi. 7 pi over 6. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 is already on the unit circle at 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. 11 pi over 6 and 12 pi over 6 is the same as 2 pi. Finally, each spoke is associated with an ordered pair, and again it's important to note that the radius is 1. Here's the ordered pair 1, 0, 0, 1, -1, 0, and 0, -1. The spoke in quadrant 1 that's closest to the x-axis has the ordered pair root 3 over 2, 1/2. We established where that came from in a 30, 60, 90 triangle in our previous lesson. If I were to reflect that same exact ordered pair into quadrant 2, the only thing that would change is that my x coordinate would be negative. In quadrant 3, both coordinates are negative. And in quadrant 4, x is positive but y is negative. Let's do the same thing with the other ordered pairs. In quadrant 1, we've got root 2 over 2, comma root 2 over 2, which we established comes from a 45, 45, 90 triangle. In quadrant 2, it's the same exact coordinates, however, x is negative. In quadrant 3, x and y are negative. In quadrant 4, x is positive, y is negative. Finally, we've got 1/2 comma root 3 over 2 in quadrant 1. In quadrant 2, the negative is associated with the x coordinate. In quadrant 3, negatives with both coordinates. And in quadrant 4, a negative with the y coordinate. We can use this unit circle to evaluate trig functions for any special angle. Keep in mind that every ordered pair on this unit circle represents the cosine of an angle and the sine of an angle in that order, cosine first, sine second. We also want to recall that the tangent is equal to sine over cosine. And for the other 3 trig functions, we just use reciprocals. This information will help us evaluate many, infinitely many trig values of special angles on the unit circle.